The topic of this video is overcharging or overvoltage at the battery on the original Chrysler charging system caused by excessive voltage drop in the charging system regulation reference circuit. Includes some suggested repair options, diagnosis, and procedures. Pretty common issue on the 1970 and up electronically regulated system. Common too, throwing regulators at the problem doesn't resolve the issue. Voltage drop is the loss of voltage due to resistance while current is flowing. The more resistance and or the more current flowing through a given conductor, the more voltage drop. In this case, the total of small amounts of voltage drop across various conductors and terminations in the reference circuit can be enough to interfere with the line voltage seen at the battery. For these diagrams and discussion, the voltage drop numbers shown are completely arbitrary, but are typical when experiencing this issue. In this case, we're showing 15.5 volts at the battery while the engine is running, when it should be closer to 13, 8, 14 volts. What's going on? Well, let's look at where the regulator is picking up its reference voltage right on ignition 1. In this case, this regulator is preset internally to regulate at 13.8 volts. It's going to get that reference right off of ignition 1 at that connector to the regulator. But it has a ways to go to get to the battery. If you follow along in these circuit diagrams, we have to go through the bulkhead connector, terminal 23, ignition 1. There's 2 Packard connectors there. And if they're in reasonably good shape, there's going to be a little bit of voltage drop there. If not, there'll be more. Following along ignition 1, the next step is the ignition switch Molex connector, the bottom of the steering column. And we have another connector there. That's a Molex terminal. It could be there could be some more voltage drop across that Molex terminals. Then we got to go through the ignition switch to get to the battery. The switch itself internally can have some resistance. Most of them do. There's some voltage drop in the actual switch itself. Now we're going back to the Molex at the bottom of the steering column, again on the battery feed connection. Another set of Molex terminals there. There could be another loss of voltage right there. From there we go to splice 1. And from splice 1 we got to go through the ammeter. If there is any resistance or issues with the connections at the back of the ammeter, we're going to have some voltage drop there. In this example, we've lost 0.2 of a volt going through that ammeter, either at the terminals, could be resistance at the ammeter stud head to bus connection, loose screws, loose nuts actually. From the ammeter, we got to go back to the bulkhead connector, number 16. We could have some more voltage drop going on here. In this example, we've lost 0.2 of a volt. Maybe there's a little corrosion going on here after, 50 years. Who knows? And from there, there's usually another disconnect at the fusible link, either a Molex or a Packard terminal going on there. We've lost a little bit of voltage on that connection. By the time we get to the battery, we now have a 1.7 volt difference between the reference at the regulator and what the battery sees. The regulator is going to keep cranking up until it hits that 13.8, and now we've got 15.5 volts at the battery. You can keep throwing regulators at it, but it's not going to solve the problem. There's an aftermarket version of this regulator that's adjustable. You can try to compensate for this by, toning this down a little bit to get our charging volt somewhere where within a normal range. That kind of masks all this stuff. Doesn't really address the problem. What you need to do is go through these connections and reduce the resistance as much as possible. Especially this guy at the bottom of the column, a big source of problem. The current that's creating this voltage drop is typically charging current, or in this case, load current. The vehicle loads that are pulling current through this add to this problem. One of the quickest ways to test and see if this is an issue for your overcharging is to run a temporary jump lead or wire from ignition 1 directly to the battery. If this results in a normal looking charging voltage at the battery, something much more closer to what the regulator reference point is, then you know you have a voltage drop problem in your reference circuit. More precisely, you can use a voltmeter and you can measure this voltage drop. For the nitpickers out there, the little picture of the voltmeter, the little flute guy there, it looks like it's set on AC. We don't want that. We need to have that on DC. And you can take measurements at various points in your reference circuit to isolate just exactly where the issue is. At this point, you can actually measure. There's a 1.7 volt difference between ignition 1 as measured at the field terminal, ignition 1 field terminal, and the battery. Moving your probes at various points in the regulation circuit can kind of pinpoint or isolate where the highest voltage drop is, or where the biggest problem in the circuit is. An example of that would be measuring at various points in the reference circuit from the battery to where the highest voltage drop is located. Correct. Move on to the next. You can also isolate. This would be an example of isolating the ignition switch itself. What is the voltage drop across the switch contacts? Stick your probes right into the Molex on your red battery feed drop and the blue ignition 1 terminal, and that'll tell you exactly what you have going on voltage drop wise inside the ignition switch, which you really don't have any control over other than replacing the switch. Later Chrysler products, especially with larger output alternators with more field current, incorporated something referred to as a field relay. This is another way you can resolve this. This is essentially a bypass of the traditional reference circuit with the use of a relay. And this gets you, when that relay is activated, being controlled by ignition 1, it essentially places that bypass wire that we did a moment ago between the ignition 1 at the regulator and the battery. And this is closed. It gets a more accurate reference voltage to the battery. We should now have the same voltage measurement at the battery that we do at the regulator reference. It's a pretty cheap little fix, really. That about covers voltage drop causing overcharging, over voltage at the battery. For some other information about causes of high resistance at these terminals, there's a couple of links in the description to some other videos about loading the charge path and the charge circuit on this system and related ammeter issues and connection issues. Another link links off to some information about that Molex connector at the bottom of the steering column that seems to be quite troublesome. A great deal of resistance and voltage drop is created there on this system.